Hey everyone, so I've decided to do a mini series on graphing a sphere because I want to have to split this into multiple videos because I can't try to do everything in one video because there's a lot of fundamentals that I want to discuss first. So the way we're going to do this is we're going to be using discrete points. What I mean by that is we're going to be approximating circles with polygons. So here's an example. I'm going to write a function f as it's going to be we're going to need center points x and y. So we use h and k normally. We also need to know how many points there are. All right. But h and k that is where a circle is going to be centered at, and this n is how many vertices we want to approximate the circle with. We're going to be using trigonometry for this. So we're going to first assume that we are centered at 0, 0. So this is like the simplest case, and we're gonna need a step size. So that one I believe is 2 times math.pi divided by how many points we're using. This will take us all the way around the circle. And in this case, what we're going to put in here is I'm going to push. Okay, we need an x and y here. So if we're assuming that it's 0, then that's going to be n. Oh, that's right. We're missing the radius. R times math dot sine of I, and then we also need R times math dot. Okay, so this is supposed to be sine. So sorry. What's inside of it? This one doesn't really matter, but this value will, and same with, okay, let's start with 4 points. Okay, so we're starting at one here. So I know this is hard to read, so to make it a little bit easier, I'm going to see if this satisfies the condition. And let's make n4. T squared plus, this is x squared plus y squared is equal to r squared. Circle that. Okay. Just to double check, make sure that we're all getting a result that should give us false. Okay, cool. And now I can like populate this with however many points we want. We want 30 points. Wait, now it's false because I think it's because we're losing accuracy. Use 6. Oh, did I make a mistake? Okay, okay, now I'm just checking how many points are in here. Okay, we make this triple FN, right? All the points. So as you see right here, I think this number is meant to be 0 because this is really small. This is also meant to be 0 because that's also really small. So let's actually try some of these points before we end it. Let's try 6 points. All right, I'm gonna leave this for a moment so you can have a look at it. I'm gonna cut to Desmos just to show you these points. Okay, so I have plotted these 6 points on here on this table. We can also change this to, let's make them lines. Then what I've done is I put in the original equation of this circle and you can just check out how accurate these points are. I know at first glance it looks like we're losing resolution on the circle here because it looks like, okay, well, why can't we use this high resolution circle um, instead of using this low resolution here? And my point is that when we uh, start grabbing a sphere, we won't be able to do this unless you know of a way we can make high definition spheres. All right. Um, so in the next video, I will show you how to convert this into x and z rather than just saying x and y, because is x and y? Yes, you're right. You can we can just easily use this equation 2 in here instead of equation 1. But we're going to broaden that out. So we got to start somewhere, and so I just start at this level here. All right. If I confuse you anyway, feel free to ask. Otherwise, I'll see you in the next one.